we're going to look at doing the continuity of CPC and polarity test in this installation. Got to be very careful as well, because in an SY Flex we've got two black conductors labelled 1 and 2, which hopefully have been identified correctly at both ends as line and neutral, and a green and yellow protective conductor. So you can see how important polarity is going to play in this part of the video. So we're going to get ready for that first test, continuity of CPC, including polarity. So we're ready to set up our MFT tester, and this time we're going to be using our plugging lead that comes in the set of leads within the box itself. And as I said in the opening part of the presentation, we're actually going to carry out the first test between line and neutral as part polarity. So we're going to need both the blue and red connections on the end, and we're going to insert those in the top of the machine, remembering as it's a dead test we're only going to use the red and green sections. So if I put my red one in and I put my blue one in, I will be ready to test between live conductors. I need to set my instrument onto the ohm scale, and I also need to be using this adapter in order that I can get into my 16 amp industrial socket. That requires this plus the original lead to have its resistance removed. Let's do that next. So I'm going to plug in here like so. So I've got both the lead and the adapter socket to have its resistance removed. I'm going to use crocodile link to link out my live conductors within my industrial plug, like so, and then I can see if I've got a reading. Okay, I've got a reading, need to remove that resistance, so I press the test button once. Notice it isn't flashing, so we are at 0 at that stage. We're ready to carry out the first test, which is part polarity, testing between line and neutral. So if we plug in down here into my industrial socket outlet with my plug adapter lead, I have a reading of 0.06. It isn't recorded, it's part of the polarity test. It requires us next to go on and do a test between line and CPC. You'll note in the consumer unit, I've linked together the disconnected line to the neutral bar, and I've used my red and blue connections in the top of my Megger MFT in the red and green sections. So I've measured a resistance between line and neutral as part polarity. Those two conductors could be the wrong way round. How do I prove that? I'm now going to test between line and the earth bar where the CPC is. And if I get a reading then, I will have completed the polarity check, the 3 pins in the right position, and I will achieve in the second part of the test my reading for R1 plus R2, and I'll record that in ohms, and I'll get a chance then to tick the polarity box. Let's move to the next part between line and CPC. And we now need to test between line and our circuit protective conductor. So if we remove the one that was measuring for the neutral, and we insert the green one, so we're now into the protective conductor. And let's just confirm that we have a resistance of 0 on our actual lead and plug top. So if we go onto the earth pin, and then if we go onto the live conductor as well, let's make sure we get the right one. So we're on there. We've got a reading, we need to zero out. Oh no, we're at 0, so we're okay. So we're ready to carry out the next test, which will complete the polarity test and give us a reading we record as our continuity reading in ohms under the box heading R1 plus R2. Let's see what reading we get. So we have a reading of, we've got a reading of, again, 0.04 this time. I've linked together in my consumer unit the line conductor, which is disconnected to my earth bar, and it's settled in, and we record the reading, in this case, of 0.03 in our box heading R1 plus R2, and we can tick the polarity box before moving on to our insulation resistance test next. So the conductors in the consumer unit have been returned into their terminating points and re-torqued up, so up to the required torque setting. Circuit breaker is off, but there's no electronic components in there. We know that, but our RCCB is off because there is electronic components in there. So we obviously have the breaker and the RCCB on the test off because the test will go up and out through the circuit, but the insulation resistance will also pass the 500 volts down through the breaker and across the bottom of the RCCB. So if we had it in the on position, there is a chance the 500 volts could damage the electronic components if they were situated here. So we're going to set our instrument up to measure 500 volts in the Megger ohm scale. Let's do that next. So round to there. And we're going to test our outgoing conductors. We know the reading should be greater than 1 Megger ohm for an existing installation, Megger standing for million. Further investigation when the circuit has a reading of 2 Megger ohms or below. And for a brand new installation, this insulation resistance test needs to be greater than 20 Megger ohms. We expect this machine to read actually greater than it can read, so over 999 Megger ohms. Let's do that test next. So we're going to probe onto the line and onto the earth bar. Try and keep my hands out the way as best I can. I've got a read in greater than the machine can read, greater than 999 mega ohms. I move across, move on to the neutral and line, again trying to keep my hands out the way as best I can. Greater than machine can read. And then finally, let's go between the earth bar and neutral bar, a reading greater than the machine can read. So in this video, we've carried out the continuity of CPC and included the polarity test at the same time. And we know that we tested first of all between line and neutral, a reading we didn't record. Then we tested between line and CPC. We record that reading as R1 plus R2 in our test paperwork, and we tick the polarity box. We followed it off with insulation resistance. A couple of key things to remember. The socket outlet itself needs additional protection by an RCD rated at 30 milliamps or below. Our RCD in here is rated at 30 milliamps. The rule under the 18th edition is all socket outlets up to including 32 amps need additional protection by an RCD rated at 30 milliamps and below. We know some other things. Final circuits wired in SY flex are frowned on. We've used it as part of a mimicked exercise for the 5357 and not suggesting it's good practice to do so. And we also know that the cable tray itself has to be earthed by the awarding body in their assessment, but we understand in the classroom that we didn't need to earth that because it's neither an exposed nor extraneous conductive part. So once again, I hope this video has been some help.